Good morning, Townview. So today we're going to be working on the chemistry review. This is the last one that I posted, and it's got a lot of release questions from the ACP. So I'm just going to run through it just to show you guys how I would solve every one of these problems. So question number 1 says, what statement best describes an element? So what we know about elements is that they are made up of one type of atom. So let's look at the answers that we have up here. So it says any combination of 2 or more atoms. No, we know that's a compound. Pure substance made of only one type of atom. That's the answer. A substance containing only carbon atoms. That's not right. Any kind of crystal. No, that's not right. All right, so what's a homogeneous mixture? We know that homo means same. So it's a mixture that looks the same throughout. Another word I like to use is going to be uniform. So any one of these that's uniform, you can't differentiate the things that are in it, would be considered a homogeneous mixture. So homogeneous mixtures are also called what? They're also called solutions. So a hydrochloric acid solution, it's just hydrochloric acid in some water. That's a solution. Which of the following is not a homogeneous solution? So if you look at coffee, you can't really see the particles in coffee, so that would be considered homogeneous. Vanilla milkshake, also homogeneous. A pizza, you can see the components in a pizza. So you got the bread, the sauce, the cheese. So that would not be a homogeneous mixture, that would be heterogeneous. And then of course, you know Kool-Aid, that's a homogeneous mixture. The atoms in a solid are very close together and what? They don't flow around each other, or else they would be called fluid. So they're not fluids. So we can cross this one out. Vibrate in place, that's true. So the atoms in a solid, they're very close together, but they don't stand still, they vibrate in place. So they don't stand still. And they don't have high energy unless they're a really high temperature, but that's really unrelated. Select all the following that are pure substances. So pure substances, there are 2 categories that fall under pure substances. There are elements, which are made up of one type of atom, and then there's compounds that are a combination of 2 or more atoms that are combined chemically. Alloys are not considered a pure substance because they're a mixture. They're a mixture, not a compound. So I guess E would have been the correct answer. All right, so sublimation. So sublimation is a word that they're definitely going to use. You're going to see this on the ACP. Sublimation is the one people like to forget. That's when a solid turns into a gas without becoming a liquid first. So that's what sublimation is. And we call this a phase change. Another one that you're probably going to see is when a gas turns into a solid, a solid, without becoming a liquid first. And this is called deposition. So you're probably going to see one of these words, and they're going to want you to confuse them for chemical changes. But you need to know that all phase changes, whenever something goes from being solid to liquid, liquid to gas, all of these are considered phase changes, which are all physical, not chemical. So sublimation is an example of what? It's not a homogeneous mixture. It's not a heterogeneous mixture. It's not a chemical change. It's a phase change. Or a physical change. Which of the following changes is a physical change of matter? So water evaporating. Evaporation is one of the phase changes that we've talked about. Burning paper, that's a chemical change. A rusting nail, that's a chemical change. And silver, silver tarnishes. If you've ever had anything that's silver and you see it turn a brownish color, that's silver tarnishing or silver oxidizing. It's just reacting to the air around it. And that's a chemical change. Which of the following changes is a chemical change of matter? All right, so ice melting to produce water. Nope, that's just melting, and melting is a phase change. Vinegar combining with baking soda to produce carbon dioxide. So because we produce carbon dioxide, there was a chemical change. This is our answer. Water boiling to produce water vapor. That's a phase change. Liquid silica solidifying to form glass. That's also a phase change, which is physical. What's the difference between a mixture and a compound? So mixtures are not chemically bonded. Compounds are chemically bonded. Let's see our answer choices, though. All mixtures have uniform composition. That's not true because there's homogeneous and heterogeneous mixtures. Mixtures can be separated by physical processes. Compounds require chemical changes. So this one is true. Mixtures are made of at least two different elements. That's not true. It's because they're not necessarily elements. They can be made of anything. That's, all mixtures are heterogeneous. That's not true. There are two types of mixtures. Which of the following is a pure substance? So it's not air. Air is it's a combination of O2, N2, CO2, all types of gases in the air, and they're not chemically bonded to each other. So they're all independent of each other, and because of that, we would consider this a mixture. Granite is also a mixture. If you've ever seen granite, it's an igneous type of rock that just a bunch of different rocks. So this is also a mixture. Water, this is a compound, and compounds are considered pure substances. So that's going to be our answer. And stainless steel is a mixture of metals called an alloy, and alloys are mixtures, not compounds. All right, the table shows two isotopes of an unknown element. What is the average atomic mass? So this type of problem is fairly simple. You just got to set it up right. So what we're going to do is multiply the mass by the abundance, and this is what it's going to look like. So 10.013 times 19.8 in parentheses, and then we're going to add to that 11.009 times 80.2, close parentheses, and then we're going to divide this whole thing by 100. So let's grab our calculators, plug that in real quick. All right, when I plugged this into my calculator, what I got was 10.81, 10.8117, but that's going to round down to 10.8 AMU, and that's C. All right, next question. Which is the correct Lewis structure for fluorine? What you want to know about Lewis structures is they always show the valence electrons. They don't show total electrons, just the valence electrons. So we're going to look at our periodic table, find fluorine. Fluorine is in group 17, and group 17 have 7 valence electrons. So our answer choice is going to be C. The atomic mass of an element is defined as the weighted average of the element's what? So we answered a question regarding average atomic mass a couple questions ago. And the average atomic mass is going to be the average of all naturally occurring isotopes. So we don't just get the least abundant. We don't just get the most abundant. We get all naturally occurring isotopes. Not all elements are radioactive, so it's not just the radioactive elements. It's all naturally occurring isotopes. All isotopes of helium contain what? So to answer this, you need to know what an isotope is. An isotope is going to be the same element with a different mass. So an example of that would be, so lithium, regular lithium, has 3 protons and then 4 neutrons. Let me fix that. 4 neutrons. And then it's got a mass of 7. And then we have lithium-8. Lithium-8 is also going to have 3 protons. It's going to have 5 neutrons, and it's going to have a mass of 9. Or no, it's going to have a mass of 8, my bad. And then there's lithium-9. And lithium-9 is going to have 3 protons. It's going to have 6 neutrons, and then it's going to have a mass of 9. So what do all of these lithiums have in common? They all have the same number of protons. If the number of protons changes, the element changes. So all isotopes of helium, they have to have the same number of protons. If they don't have the same number of protons, then it's not helium anymore. So all isotopes of anything are going to have the same number of protons. The thing that's different is always going to be the number of neutrons. All right, 15 says argon, krypton, and xenon are what? So if we look at our periodic table, we're going to find that argon is 18. Just below it, you have krypton, and just below that, you have xenon. All of these are group 18 elements, and group 18 elements are called, not halogens, they're called noble gases. All right, let's move on. What's the formula for magnesium oxide? So to answer this, we need to know if this is going to be ionic or covalent. So ionic, just so y'all remember, ionic is going to be a metal plus a nonmetal, and then covalent is going to be nonmetal plus nonmetal. In this case, we have magnesium. Magnesium is a metal, so this has to be ionic. And when we're dealing with ionic, we need to plug in our charges first. So magnesium is going to have a charge of +2, and oxide has a charge of -2. So we're only going to need one of each element. So we can crisscross, put a 2 here, put a 2 here, and then reduce. But the correct answer is going to be A. What we want is a net charge of 0, and +2 and -2 equal 0. Just know, though, that when it's ionic, this will not be your answer. It's going to be reduced. So just think about those puzzle pieces that we were working with before. So this is what a +2 looks like, and then a -2 is going to look like this. And it only you only need one of each to form the bond. All right, next one we have is iron sulfide. So iron is a metal, so this is ionic. But iron is also a transition metal. And with transition metals, we always need to include charges. If we don't include the charge, the answer will be wrong. So transition metals, they don't have a charge given to us by the periodic table. So we have to get that from what it's bonded to. It's bonded to a sulfur, and sulfurs have a charge of -2. And because we have one iron bonded to this -2 charge, the iron has to be a +2 iron. So our answer is going to be iron 2 sulfide. All right, next one says, which of the following models correctly represents the compound phosphorus trichloride? So it's definitely not this one. We've never seen a compound that looks like that. It's also not this one. Doesn't have enough chlorines. And then this one right here, they just mixed it up. So they gave us 3 phosphorus, 1 chlorine. So the correct answer is going to be A. Which compound is formed when aluminum bonds with fluorine? So what we know about aluminum is it has a +3 charge. Fluorine has a -1 charge. So how many fluorines do we need per aluminum? We're going to need 3. So we just crisscross. The aluminum gets 1, the fluorine gets 3. So our answer is going to be C. All right, use the electromagnetic spectrum to answer the next question. Which type of electromagnetic radiation has the greatest energy? So the greatest energy, that's going to be the most dangerous type of radiation, which we've talked about being gamma rays. So gamma rays, these are the ones that are very much cancer-causing. They cause your DNA to denature, which is bad for your DNA. Just remember, gamma rays are the most dangerous. If you're asked about greatest energy, that's going to be gamma radiation. Radio waves are around us all the time. They're very harmless. So if you were asked for the least energy, of course it would be radio waves. But in our case, gamma rays will be the answer. What is the formula for calcium permanganate? So permanganate is a polyatomic ion. So we're going to have to turn to the back of our periodic table. And the formula for permanganate is MnO4. And it's got a charge of -1. So this has a charge of -1. And then calcium has a charge of +2. So when we have a +2 and a -1, we just crisscross. So for every 1 calcium, we're going to have 2 permanganates, and that's going to be answer choice C. All right, next one. What is the name of the molecular compound with the formula P2O5? So here we have a covalent compound. We have 2 nonmetals bonded together. And here we just got to remember our prefixes. So P2, that's going to be diphosphorus, and then 5 oxygens, that's going to be pentaoxide. So pentaphosphorus dioxide is not right. Decaphosphorus, that means 10, that's not right. Diphosphorus pentoxide, that one's correct. Diphosphorus monoxide, that's not correct. So C is our answer choice. All right, so for the next one, which represents the ground state electron configuration for manganese? So here we're looking for manganese, that's Mn. And manganese is number 25 on the periodic table, so it's a transition metal. And and the reason I put 25 here is this is the number of electrons we have. So our answer choices, they have to have the correct number of electrons. So let's go ahead and count them up. So that's 10, and that's 5. So this has 25. This one's the same, 10, 10, and 5, so this is 25. That one's 10, and then plus however many those are. So 2 plus 6 is 8, plus 7 is 25. So these also have 25 each. So we can't eliminate any answer choices by counting electrons. But we can eliminate answer choices by looking at the periodic table and knowing what manganese should end in. So manganese is right here. So 1, 2, 3, 4, 5. Manganese sits right there. And we've talked about this before. So this is called the S block. This is called the P block. This is called the D block. The S block starts at 1s. The P block starts at 2p. And the D block starts at 3d. So manganese is going to be 3d, 1, 2, 3, 4, 5. It should end in 3d5. The only one that ends in 3d5 is going to be answer choice A, so A is going to be our answer. What's the number of atoms in 3 grams of gold? So here we're doing a conversion, a two-step conversion. And the way we did those when we were working on them initially is we would do the train track, and then we would plug in our given information. So we have 3 grams of AU, and first thing we need to do is convert to moles. So I'll draw you all the little diagrams. So mass to moles to atoms or particles. So to go from mass to mole, we need to divide by molar mass. To go from mole to atom, we need to multiply by Avogadro, which is 6.02 times 10 to the power of 23. This number, just so y'all know, it's going to be available for you on the STAR resources. So if you look at your periodic table on the ACP, you're really going to have to look through it. I'll try to show you guys. Actually, I'll show y'all right now. Let me pull it up. So this is the periodic table that you guys are going to get on the ACP. And I never gave you these first 2 pages because you haven't really needed them. For semester 1, we only need the second 2 pages, which is the periodic table and the polyatomic ions. But you're going to have the first 2 pages included for you. And if you look through them, you'll find Avogadro's number. Avogadro's number is right... Where'd it go? There it is right there. No, that's not it. Avogadro's number. And it's labeled for you, which is really nice. So you're going to find it under constants and conversions. This is if you forget this number. But we've been doing so much practice, I don't think any of you will. But just know, that number is available for you when you take your test. So let's go back to the test. All right, so because we have grams at the top, we're going to be putting grams at the bottom. And the grams we're putting in is the molar mass of gold, which is 197 grams. So 197 grams for every 1 mole. So 1 mole goes at the top. And then our last step is to multiply by Avogadro's number. So 1 mole of AU, we're going to put 1 mole of AU down here. And 1 mole of AU is equal to 6.02 times 10 to the power of 23. So first thing we're going to do is 3 divided by 197, and then we're going to multiply by Avogadro's number. So go ahead, plug that into your calculator. All right, so I got 9.167 5 to the power times 10 to the power of 21. So this is going to round to 9.17 times 10 to the 21, so A is the correct answer here. We could have easily eliminated a couple of answer choices just by looking at this. Because the molar mass of gold is 197 per gram, and we only have 3 grams, we have less than 1 mole. So the answer that's equal to 1 mole can't be correct. And the answer that's greater than 1 mole also can't be correct. So really, you guys were just going between these 2 answer choices. So if you get stuck on a question, make sure to eliminate bad answer choices. All right, next one says electronegativity measures the ability of atoms to attract a bonding pair of electrons. And which diagram correctly identifies both the period and group trends for electronegativity on the periodic table? So what's real important here is that you remember the most electronegative element. So the most electronegative element on the periodic table is fluorine. So this is the most electronegative. And then the least electronegative is going to be this one right here. So least electronegative. So the way our trend should go, it should increase as we go up, and it should increase as we move to the right. So B is our answer choice. Our electronegativity increases as you go up and to the right. And since we're on the topic, ionization energy does the same thing. So ionization energy, it also increases as you go up and to the right. But atomic radius, that one's a little bit different. It increases as we go, so radius, it increases as we go to the left and go downward. So that's just something to know. So that's the trend for radius, and this is the trend for ionization energy. And it's also the trend for electronegativity. All right, which is an example of an empirical formula. An empirical formula is one that can't be reduced. So it's already been reduced and it can't be reduced anymore. So looking at our answer choices, we have H2O2. Is that an empirical formula? No, that's a molecular formula because that can be reduced to HO. N2O2, that can also be reduced to NO. B2H6, that can be reduced to BH3. So any answer choice that's reducible is not an empirical formula. This one can't be reduced because there's nothing that's divisible by both 3 and 2. Find the percent composition by mass of lithium and lithium chloride. So to do that, first thing we're going to do, we're going to calculate the molar mass of lithium chloride. So we have lithium times 1 times 7, and then we have chlorine times 1 times 35.5. And we can multiply straight across, but because it's 1, we're just going to add them. It's going to give us 42.5 grams per mole. So for every mole of lithium chloride, we have 42.5 grams. To calculate the percent composition of lithium, we're going to use part divided by whole times 100 to give us the percent composition. So the part is going to be the mass of lithium. That's going to be 7. The whole is going to be the total molar mass, so 42.5. So in our calculators, we're going to do 7 divided by 42.5 times 100, and that should give us our answer. So 7 divided by 42.5 times 100. I got 16.47, so that's going to be answer choice B. All right, next one, the figure shows a cathode ray tube. This is J.J. Thomson's discovery. He used this to discover that electrons were electronegative. So he discovered that electrons were negative because they were attracted to the positive side. So electrons were being shot through, and he saw that they were attracted to the positive side, which told us that electrons are negatively charged. So what you want to do is associate the cathode ray tube with J.J. Thomson and electrons. So those 3 go together. What causes the atomic radius of an element to decrease across period 3 from left to right? So what they're asking here is, why do elements get smaller as we move to the right? So the reason they get smaller is because we're increasing the number of protons and electrons in the atom. And we call that the nuclear charge because it's the charge in the nucleus. So as we increase the number of protons, we're increasing the pull on the electrons on the outside. So as we move to the right, what's happening to electrons, even though they're becoming heavier, they're gaining mass. They become smaller because of the increase in nuclear charge. So C is the correct answer to this one. Matter can exist as a solid, liquid, or gas. The solid state is distinguished by its ability to maintain an ordered pattern. That's just the definition of a solid. All right, an unknown element was recently discovered and found to have the characteristics shown below. So it shares 1 electron or gains 1 electron to attain a stable noble gas configuration. So metals, they can't gain electrons. They only lose electrons. So this has to be a minus 1 charge. This is group 17. It's very reactive. That's true about group 17. It's a gas at room temperature. That's true about group 17. Readily form salts. That's also true about group 17. So halogens is the answer here. And just so we go over this, alkali metals, that's group 1. Alkali earth, that's group 2. And transition metals are going to be group 3 through 12. And of course, those elements underneath the stair step, those are included as well. An unbalanced chemical reaction is shown when the equation is balanced. What is the coefficient for SnCl2? So we're trying to answer for this one. So to do this, first we're going to split it in half, and then we're going to write out everything that we got. So we have Sn times 1, Cl times 4, and then Fe times 1. And then here we got Sn times 1, Cl times 2, Fe times 1. And then here we have 3 more Cl's, so we're going to add them to this one right here. So we have a total of 5 chlorines. So first thing I'm going to do is I'm going to multiply this one by 2. And the reason for that is I don't want any odd numbers because I can't, there's no multiple of 4 that'll give me an odd number. So I'm going to multiply this by 2. That's going to give me a total of 6 chlorines here plus the 2 chlorines that are there. So that brings us to 8 chlorines. And that also gives us 2 iron. So now we have 2 iron. I'm going to come back to this side, so let's balance this chlorine. So we're going to put a 2 in front of SnCl4, sorry. That's going to give us 2 tin, and it just multiplied our chlorine by 2, so that's 8. And now we need to come back to this side and balance the tin. So I'm going to put a 2 in front of the tin, and that's going to give me 2 tin, but it also just gave me 4 chlorines. So now I have this 4 plus this 6. So now I have 10 chlorines. So even though the tin just became balanced, the chlorine now needs to be balanced. So I'm going to come back to this side, and I'm going to multiply this tin by 3. That's going to give us 3 tin, and it's going to give us 12 chlorines. So now we come back to this side, and we need to balance the tin. So I'm going to make this 3. That's going to give us 3 tin, and now we have 6 chlorines on this side. So 6 chlorines plus these 6 chlorines. Now we have 12 chlorines on this side. So tin is balanced, chlorine is balanced. And last thing we need to do is balance this iron. So we put a 2 here, and now we have 2 irons. So it's a balanced equation. So the correct answer for this is 3, 2, 3, 2. Can this be reduced? No, it cannot. The correct answer for this one is going to be 3. What is the Lewis dot structure for a covalent compound of sulfur dioxide? So for this one, we're doing a Lewis dot structure. And Lewis dot structures, they always show us valence electrons. So first thing we want to do is figure out how many valence electrons we have. So I put copper. So sulfur dioxide, so that's going to be SO2. Sulfur has 6 valence electrons. Oxygen also has 6. But we have 2, so we're going to add 6 plus 12. That gives us 18 valence electrons. So that's how many valence electrons should be in our answer. Let's count them up. So we got 2, 4, 6, 8, 10, 12, 14, 16. This one doesn't have enough. We can cross it out. This one is 2, 4, 6, 8, 10, 12, 14, 16, 18. This one has 18, so this one could be our answer. 2, 4, 6, 8, 10, 12, 14, 16, 18. This one can also be our answer. 2, 4, 6, 8, 10, 12, 14, 16. This one doesn't have enough. We can cross it out. Now, after we've counted up our electrons, next thing we want to do is make sure that each element has a full octet. An octet is when it's surrounded by all the electrons that it wants. For most elements, that's 8. For some elements, it's less. But 8 is what you guys want to remember. So in this case, oxygen has a full octet. It's got these 2, 4, 6, 8. Sulfur here has 2, 4, 6, 8. So sulfur is also 8. And then this oxygen is 2, 4, 6, 8. So each element in this compound has an octet. So this is a good one. If we look at the one directly below it, this oxygen has 2, 4, 6. It's only got 6 electrons. This sulfur has 8. This oxygen has 8. But this can't be our answer because this oxygen is not satisfied. So B is the correct answer for this one. All right, so the next one says, what's the name of the compound FeCl3? So this one is ionic, and it's got a transition metal, which means we just need to include the charge for iron. Here we only have 1 iron with a charge, so this is actually our answer without even having to do anything. But chlorine has a -1 charge. We have 3 chlorines, so we have a total negative charge of -3. We have 1 iron bonded to this, so the iron has to be +3. So iron 3 chloride is the answer to this one. All right, next question. The sea of electrons explains why metals what. So the sea of electrons just tells us that metals are just a bunch of protons that sit in a line, and electrons are free to flow through the metals. So anytime you think about electricity, just know that that's the sea of electrons. You have the metal wire, and that metal wire is made up of metal protons, and the electrons are free to flow through. So the sea of electrons, it explains why metals are excellent conductors, not why they're reactive, and they don't accept electrons, so that's incorrect. And it's also not why they form ionic compounds. They form ionic compounds because they give away electrons so easily. So it explains why they are excellent conductors. Here we have two isotopes of an unknown element. What is the average atomic mass? So this is another example of calculating average atomic mass. So we got 10.013 times 19.8. This feels like the last one that I did. Or is this one different? Do y'all know? Let me look at my calculator. All right, so if the answer is 10.8, then I already solved this one. And the answer is 10.8. All right, so we already solved this one previously. You just gotta scroll back in the video. Gold is classified as a pure substance. Which of these properties supports this classification? So pure substances qualify, or they go, there are two categories. We have elements and there's compounds. And elements are made up of one type of atom. Compounds are going to be chemically bonded. Two or more atoms. So gold is a pure substance. Gold is an element because it's made of one type of atom. And that's just a definition. Which statement explains why metals conduct electricity? So metals hold loosely, have loosely held delocalized electrons. So delocalized electrons is important to know here. Those are the electrons that are free to flow around, and that's why metals are excellent conductors of electricity. It's not because they're hard and have high melting points or lose electrons while bonding or form covalent bonds, because they don't do that. Which chemical name and formula are correct? So potassium chloride, I don't see much wrong with this one. Well, we got to plug in the charges. So potassium is going to be +1, and chloride is -1. So that one's okay. What's the problem here? I don't know. I don't see anything wrong with that one. Let's see the next one. So the next one is carbon tetrachloride. That one's also correct. Sodium dichromate. So that is not chromate. That's just chromium. So that's why this one is wrong. Magnesium phosphide. This one is incorrect because so magnesium has a +2 charge, and then phosphide has a -3 charge, which means you need 3 magnesiums for every 2 phosphides. So the correct formula would be Mg3P2. Oh, so this one is incorrect because potassium is not P. Potassium is K, KCl. So that's why A is wrong. So the correct answer here is going to be B. So here's another one, and it brings in 3 from the previous question. So we don't need to go over these. This is the correct answer. Diarsenic, here we have pentaarsenic, which is why this one's incorrect. But these two are the same as the ones from the previous question. How many atoms are present in 2.5 grams of copper? So here we're going from mass to mole to atom, just like we did in the last one. To go from mass to mole, we divide by molar mass, and the molar mass of copper is going to be 64. So we're going to divide by 64. And then we need to multiply by Avogadro, which is 6.02 times 10 to the power of 23. So I'm going to solve it the same way we did before, just to be helpful. So we're going to put our given information here, 2.5 grams of Cu, and the molar mass of Cu goes down here. So 64 grams of Cu, that's going to be for 1 mole of Cu. And then over here, we're going to put 1 mole, and then up here 6.02 times 10 to the power of 23. So then we just plug this into the calculator. All right, so after plugging this one into the calculator, what I got was 2.351 times 10 to the power of 22. And the closest answer to that is going to be answer choice D. We know here that we have less than 1 mole, so we could have also eliminated this answer and this answer because that's equal to 1 mole. So really we should have been stuck between 2, but that's the correct answer right there. What is the correct electron configuration for an oxygen atom? So electron configuration, that's going to show all the atoms that we got. So oxygen should have a total of 8 electrons. This answer choice has 8, this one has 8, this one has 6, so we can eliminate that. This one also has 8. So if we look at the periodic table, and I can pull up the periodic table, just let me see. So here's oxygen right here. And we talked about these blocks. So S block right here, P block right here, D block right here. And the S block starts at 1S, and the P block starts at 2P, and the D block starts at 3D. And the F block, just so y'all know, starts at 4F. So oxygen is right here. So it needs to end in 2P, 1, 2, 3, 4. It needs to end in 2P4. But it should also include all the configurations that came before it. So it should include 1s2, and it should also, so this is how we go. We go 1s2 all the way to here, then we do 2s2, and then we come over to the P block, 2p4. So this is the correct electron configuration. So let's go back. So we need 1s2, 2s2, and 2p4. This one is incorrect because there's no such thing as 1p4. So that one is no good. And this one, it skips 2s altogether. So 2s is skipped in B. That's why A and B are incorrect. Which Lewis structure is correct? So for this one, we just need to look at our periodic table. So lithium is a group 1 element. It should have 1 valence electron. So this one is not correct. Phosphorus is group 15. So phosphorus should have 5. And then sulfur should have 6. And oxygen should have 6. Oxygen does have 6, which is why oxygen is correct. All right, so here we have percent composition. This time it includes 3 isotopes. This is just a reminder that we always include all naturally occurring isotopes. So we do this the exact same way. So abundance times atomic mass, 11 times 53.9 in parentheses. Then we add to that 82.5 times 57, close the parentheses, plus, open new parentheses, 6.5 times 60.3, close parentheses, and then we divide this by 100. So let's all plug that into our calculator real quick. All right, so after plugging this one into my calculator, what I got was 56.87, and that's just going to round up to 56.9, so C was the correct answer choice. Let's go ahead and move on. The molar mass of water is 18.015. What is the percent composition of oxygen and water? So to solve this one, we're just going to do part divided by whole. So the part that we're looking for is the oxygen. We have 1 oxygen, and the molar mass of oxygen is 16. So we're going to do 16 divided by 18.015. And if you want, you could just plug in the answers, or you could plug in the actual atomic mass from the periodic table, but I like rounding them. So 16 divided by 18.015, and that gave me 0.88, and we multiply by 100, and that would just give us 88.8, which is answer choice D. The molar mass of a molecule is found to be 216. What is the molecular formula of the molecule? What is the empirical formula? So molecular formula is the actual formula, and the empirical formula is a reduced formula. But the reduced formula, it has to have the correct ratio. So the ratio can't change in an empirical formula. So it tells us that the the molar mass of a molecule is found to be 216, and its empirical formula is this. So the way we solve these types of problems is we start by calculating the molar mass of the empirical formula. So N2O5, we have nitrogen times 2 times 14, and we have oxygen times 5 times 16. You multiply straight across, that's 28, and then that's 80. Then we add these together, and then that gives us 108 grams per mole for our empirical formula. And then our last step is going to be to take the molecular formula, which is 216, and then we just divide this by 108. So that's going to equal 2. And then we take this number and multiply it by our empirical formula. So N2O5, we multiply everything by 2. That gives us N4O10. So our molecular formula is B. And we can cancel answers out. So answer A is incorrect because it doesn't have the correct ratio. Answer C does have the correct ratio, but it doesn't have the correct molar mass. The molar mass here is 108. We just calculated it. And then this one also doesn't have the correct ratio. So B is the only answer here that works. The figure shows how atoms or molecules are arranged in each of the 3 states of matter. Which state of matter can be easily compressed and why? So solids are not compressible. You can't fit them in a smaller container than them. So these are not compressible. Liquids are slightly compressible. They're less than 1% compressible. So we also call these not compressible. Gases, they have so much space between them though. You can easily compress gas. You can always make gas fit in a smaller container because the gas molecules are so far apart. So these are most compressible. That lets us cancel out 2 answer choices. So C and D are both wrong. So answer A says because the particles are far apart, they have weak interactions. So that's true. These gas molecules, they don't really interact with each other. In fact, they try to avoid each other at all costs. B says it's because they have strong interactions. So they don't have strong interactions. When we're talking about liquids that are like hydrogen bonded water, those have strong interactions, but gas molecules, they have very weak interactions. Of the 3 states of matter, gas is most easily compressed because the particles are far apart and they have weak interactions with each other. That's the same as the last question. All right, so this is another average atomic mass. Based on the data on and the periodic table, what is the unknown element? So the unknown element, over 99% of it has a mass of 14. So if we look at the periodic table, what has a mass of 14? It's nitrogen. And I can prove it. So nitrogen has a molar mass of 14.07. So the answer is nitrogen. Which statement is an example of a chemical change? So here we're looking for not a physical change. So when you tear a piece of paper, that's a physical change. When butter is melted from a solid, when butter becomes a solid when cooled, that's just freezing, and freezing is a phase change. Water droplets collect outside a glass of water, that's condensation. A piece of wood burning. So this is a change in chemical formula. So D would be a chemical change. A chemical property of hydrogen is that, so it doesn't really matter that it's hydrogen. What you're looking for here is a chemical property. So it's colorless and odorless, that's physical, has a boiling point of whatever, that's physical. So answer choice C uses the word reacts. Anytime you see the word reacts, just know that's a chemical change. And then density, that's also a physical change, or that's a physical property. Which statement describes the arrangement of atoms within a metallic lattice? So metallic lattice is, it's just the order that metals go in. So it describes the shape of metals and how they arrange themselves. So this is basically what a lattice is, and it just describes the bond of metals. So what we know about metals is their protons are in fixed positions and their electrons are free to move around. Answer choice A says that they're both in fixed positions. That's incorrect. Answer choice B says that they're both free to move around. That's incorrect. C says cations move freely. That's incorrect because cations are fixed. So answer choice D, cations are fixed, valence electrons move freely. Which statement describes the arrangement of protons and valence electrons within a metallic lattice? That's the exact same question, so D. All right, here we have some balancing equations, so let's go ahead and knock these out. So first thing we do, we cut it in half and then we arrange everything. So we have 1 aluminum, we have 3 bromine, and then we have 2 iodine. Over here we have 1 aluminum, 3 iodine, and then 2 bromine. So we're gonna start with the iodine. No, let's start with. So the aluminum's already balanced. We can start with the iodine, but there's really no point in that. Actually, let's start with the iodine. So over here we have I3. Over here we have I2. We have to multiply iodine by 2 so that it can be divisible by this 2 right here. So we're going to multiply this by 2. That's going to give us 2 aluminums. It's going to give us 6 iodines. And now we can actually balance it on this side. So to balance it on this side, we're just going to put a 3 in front of I2. So now we have 6 iodines, and iodine's balanced. And then we come over here to do bromine. Bromine, we got to do the same thing because bromine is also packaged in 2s. So we multiply this by 2, and that's going to give us 6 bromines, 2 aluminums. And then over on this side, we need to multiply this bromine by 3. That's going to give us 6 bromines, and now we're balanced. So the answer here is 2, 3, 2, 3. They're asking for the coefficient for I2, which is 3. All right, another balancing equation. Let's go ahead and knock it out. So we have hydrogen times 1, chlorine times 1, magnesium times 1, oxygen times 1, and then hydrogen times 2. Well, I guess we add them to these, so that's we have 3 hydrogens total. Over on this side, we got magnesium times 1, chlorine times 2, hydrogen times 2, and then oxygen times 1. So let's start with the magnesium on this side. Well, that's already balanced. So I guess we can start with the chlorine. So here we have 2 chlorines, so we need 2 here. So let's multiply this by 2. And now we have 4 hydrogens, and we have 2 chlorines. So chlorine is balanced. And then over on this side, we're going to multiply our hydrogen times 2. So 2 here. That's going to give us 4H2O, or sorry, 4H, and then it's going to give us 2O. And then over on this side, we'll have to multiply this by 2 to give us 2 oxygens. And now we have 2 magnesiums. And it's not balanced yet. So now we got to balance this magnesium. So we put a 2 here. So that gives us 2. And now we have 4 chlorine. So we need to come over to this side and put a 4 in front of this chlorine. So now we have 6 hydrogens, 4 chlorines. No, we have more than 6 hydrogens. So we have 4 hydrogens here. No, we have 8 hydrogens. All right, so this is balanced now. We have 8 hydrogens. So now we come back to this side. We need to multiply this H2O by 4. That's going to give us 8 hydrogens here. It's going to give us 4 oxygens. And then we need to come back here, put a 4 in front of this. So now we have 4 magnesiums and 4 hydrogens. Okay, I've been doing this wrong because this oxygen multiplies by 2. So we actually have 8 hydrogens here. All right, so this needs to stay at 2, which means magnesium should stay at 2, and oxygen would stay at 2. All right, so we have 4 oxygens here, which means this needs to be at 4. All right, we're balanced, I think. Let's count them up again. So here we have 4 hydrogens plus these 4 hydrogens, so that's 8. We have 4 chlorines, we have 2 magnesiums, and we have 4 oxygens, so that's right. And then over here we have 2 magnesiums, 4 chlorines, 8 hydrogens, 4 oxygens. All right, so this is correct now. So we're looking for the coefficient for H2O. The coefficient for H2O is 4. If anyone sees a problem with this, please let me know. All right, next one. So Rutherford, you always want to associate Rutherford with his gold foil experiment. And what he discovered in the gold foil experiment is a dense nucleus, and the dense nucleus is surrounded by empty space. So he figured out that most of the space in an atom is empty space, and all the mass is placed in the nucleus. So when he shot helium particles through, a majority of them went all the way through. Some of them were bounced off because they hit the nucleus, but that's him figuring out that all the mass of an atom is right in the center. So he figured out B, that positively charged particles exist in a small centralized nucleus. All right, so the next one, 2 lasers produce light with the same intensity but different colors. Laser Y produces yellow light, laser B produces blue light, and then they give us the frequencies. So frequency for yellow is, it's 5. I'm just gonna round it to 5. So frequency is 5, and then B, the frequency is, we're gonna round that to 6. So what you wanna know is, so a higher frequency means a shorter wavelength. So this is a shorter wave. And the shorter wave has the higher energy. So answer choice A is correct here. Photons from laser B have greater energy than photons from laser Y. Just because these have the shorter wavelength, that means that they have the higher energy. Which is the correct electron dot formula for the covalent compound NH3. So for this one, you can cancel out all of these answers because of one rule that they keep breaking, and that's that hydrogens can only make 1 bond. Here we have a hydrogen with 2 bonds, so this is incorrect. Here we have 2 hydrogens with 2 bonds, so this is incorrect. Hydrogen with 2 bonds, this is incorrect. That leaves us with 1 possible choice that works. But let's count up our valence electrons. Nitrogen should have 5. And then hydrogens are going to be 3, so we should have 8 valence electrons. That's 2, 4, 6, 8, and that's our correct answer. All right, the diagram shows the colors and wavelengths of the visible part of the electromagnetic spectrum. Which set of colors is listed from highest to lowest frequency? So highest frequency is going to be, the shortest wave is going to be the one with the highest frequency. So HF is going to be here, and then lowest frequency is going to be up here because it's a longer wave. So we just want them going from highest to lowest frequency, which means we want to go from blue all the way to red. So violet, red, indigo, that doesn't work because that goes here, then here, then here. So no. Blue, green, orange. So blue, green, orange. This one works. Red, blue, that doesn't work. Orange, violet, green, that doesn't work. So B is the only answer that works here. Which element makes up 20% of the mass of NH4ClO? So first, we're going to calculate our molar mass. So NH4ClO, we have nitrogen times 1 times 14, and then hydrogen times 4 times 1, Cl times 1 times 35.5, and then O times 1 times 16. And then we just add these together. So I'm going to use my calculator. Actually, there's no need. So we got 10 plus 5, and then 5, 1, 4, 5, 6, 7. So we got 75.5. That's our molar mass. And then we just need to calculate the percent composition for each one. So nitrogen is 14, has a mass of 14, so we're going to do 14 divided by 75.5. And that gives us 18.5%. Did I miscalculate? Yeah, I miscalculated. This one doesn't go here. This one goes here. So let's calculate that again. So we have 16. So 6 goes here. Then we got 1, 4, 5, 6. So it should be 66.5. So 66.5. All right, so 21% for nitrogen. And then we're going to do 4 divided by 66.5. And that gives us 6% for hydrogen. And then 35.5 divided by 65.5. That gives us 54%. And then last one is 16 divided by 66.5. And that gives us 24%. So the answer choice here is going to be nitrogen. 4 students were given samples of 2 substances and told to classify them as pure substances or mixtures. Let's take a look at the table. So pure substances, either elements or compounds will work. So silver, that's correct. Air is a mixture, so that doesn't work. Sodium works. Steel is an alloy, so that doesn't work. So our answers have to be either A or C. Mixture, hydrogen is not a mixture. Hydrogen is an element, so we can cross that one out. Salt water is a mixture, so answer choice C is correct for this one. How many moles of chromium are present in 156 gram sample? So here we're going from atoms to moles, so this is a one-step conversion. We're just going to do 156 divided by the molar mass of chromium, which is 52. So 156 divided by 52, that gives us 3, so we have 3 moles here. What is the correct electron configuration for gallium? So let's find gallium on our periodic table. So here's gallium right here. And so gallium is going to be, so this is 2p, this is 3p, this is 4p. So gallium is at 4p1. And then it should have everything that comes before it. So directly before it, we got 3d10, 4s2, 3p6. So that's everything that we need for gallium. Let's come back here. So we said that it should end in 4p1. All of these end in 4p1. But another thing to know is for shorthand configuration. When you're doing shorthand, the first thing that comes after your noble gas needs to be an S block element. So if we were like, we need to have 3s2 or 4s2 before we can go to the 3d10. So answer choice D and C are both wrong for that reason. So our answers have to be one of these two. If we count our electrons, we're going to see that this one is missing 2 electrons. They're missing from the 3D block. So our answer choice is going to be A, because this one is missing 2 electrons. If you count them up, you'll see that that's the case. What is the name of the compound SnSO4 so SO4 is going to be sulfate, and sulfate has a charge of -2. We have 2 sulfates, so the total negative charge is -4. We have 1 tin, so the tin has to have a charge of +4. So B is the answer here. All right, next one, reacts vigorously with metals. So it's not a metal. Or no, they're telling us bromine. So a chemist researches an element, the element bromine, and records the properties he observes. What is a physical property of bromine? So we're looking for a physical property. This is reacts, so we know that's chemical. Combines with hydrogen, that's a chemical change. Does not react with hydrocarbons, that's also a chemical property. It's reddish liquid, that's going to be it. That's a physical property. What is the percent composition to the nearest tenth of potassium in potassium permanganate? So first thing we need to do is calculate the molar mass. So KMnO4. So potassium times 1 times the molar mass of potassium, which is 39. And it wants us to round to the nearest tenth, so I'm going to do that. I'm going to do 39.1. And then Mn, we have one of those, and that's got a molar mass of 54.9. And then we have oxygen times 4 times 15.99. And then I'm just going to add these together. So 39.1, or no, we need to multiply first. So 15.9 times 4, that gives us 63.6. And then we can add them together. So plus 54.9 plus 39.1. So the molar mass I got was 157.6. And then we need to calculate potassium. So potassium is 39.1. So we're just going to divide 39.1 by that. And I got 24.8. The closest thing to 24.8 would be 24.7. And that's it. Use the electron dot diagram to answer the question below. Which formula could be represented by the following electron dot diagram? So what we see here is a metal that gave away 2 electrons, and then we see 2 nonmetals that gained 1 electron each. We know that because they only have a -1 charge. So we're looking for a group 2 metal that's bonded to 2 group 17 nonmetals. So magnesium chloride, this would work. Calcium hydride, that won't work. Sulfur fluoride, that won't work because it's covalent. And CO2 also won't work because it's covalent. Which list of the 3 phases of matter is matched with the correct description of their shape? So solids need to have a definite shape, so this one is incorrect. Liquids don't have a definite shape, so this one is incorrect. This one's incorrect. So solid is definite, liquids and gases are both indefinite, so D is correct here. Which diagram illustrates the atomic radius trend from left to right of the 4 atoms in period 3? So we know that elements, they get smaller as we move from left to right. So that's what we're looking for. We're looking for a trend that shrinks as we move to the right. The only one that follows that trend is A. That's it. Atomic radius increases from top to bottom in a group on the periodic table because of what? So group 1 elements have 1 shell, group 2 elements have 2 shells, group 3 elements have 3 shells, group 4 elements have 4 shells. So really what's happening is they're gaining electron shells. And they gain electron shells because the inner shells are getting filled up. So let's read our answer choices. Electrons occupy higher energy levels that are farther from the nucleus. So that's correct. The volume of the nucleus increases from top to bottom. That doesn't make sense. The radius of the electrons increases from top to bottom. That doesn't make sense. Metals become more reactive. That doesn't make sense. So A is the correct answer. So this is a true statement. It just doesn't make sense for what we're talking about here. All right, we're almost finished. Last page. The table lists 4 covalent compounds and their names. Which formula is written correctly? So diphosphorus pentaoxide, that should be a 5, so this one is incorrect. Carbon tetrachloride, that's incorrect because that's a chlorate. Dinitrogen monoxide, that's incorrect. Sulfur trioxide, this one is correct. All right, so antacid medication neutralizes a naturally produced acid inside the stomach and helps relieve discomfort. The active ingredient in antacid medication is MgOH2, and the acid produced in the stomach is HCl. What is the name of the acid produced in the stomach? So HCl, you just need to know that that's hydrochloric acid. And that's it. We're finished. I hope this was helpful. I'll see you in class. Good luck on your ACP.